Okay, welcome back, everyone. Hope everyone enjoyed their lunch and meeting the partners sessions. We're starting off with another very exciting topic by Alexander Antukh, who's the Chief Information Security Officer at Abotis Power. And he's going to be talking to us a bit about a topic that personally I feel like is very is niche and not talked about enough, and that is securing the OT, and especially more of a case study in the energy infrastructure. So with that said, Alexander, the floor is yours.
Thank you very much for the introduction, and hello everyone. Hope you're having a great day today. So let us start. Just before that, I asked not to present myself because I really don't like the who am I part. I would rather start with where am I? So currently I'm presenting while sitting in a hotel in Bataan, Philippines. It's a country famous for its pristine beaches, world's most delicious mangoes, and approximately 20 typhoons per year. Here I work for the largest energy company of the country, which you can think of as the PGE of the Philippines, but unfortunately we don't own such a cool stadium as you guys have there. The presentation is a case study about how we built an OT security program for such a company from scratch. As we walk through the slides, we'll go from conceptual differences to deeper technical intricacies and finish with practical recommendations on how you might approach it. As it's a living program, I would appreciate your feedback at the end of the presentation, as well as connecting over LinkedIn for further questions and discussions. Okay, so let's get into it. Tomorrow, October 18, 2024, the NIS2 directive of European Union will come into force, and the organizations covered must comply with it to be able to operate in EU. There are initially 11 critical sectors and plus 7 other critical that are outlined on the slide. From them, energy is considered by many as uniquely critical. And if you think about it, to be honest, every other sector is connected. So you probably wouldn't be able to listen to this presentation, to have breakfast, to have commuted to where you are now without energy. Unfortunately, if we look at the reports, according to Scientia report entitled Anatomy of 100 Cybersecurity Incidents in Industrial Operations, it also shows that energy is the most attacked industry based on the gathered data. Okay, so we'll be talking about how OT security is different from IT security and why it's not enough to just apply the proven methods and consider it done. Like there are so many frameworks and there are many experts who already can apply it to multiple companies. Like why do we even need to talk about something like OT security? As outlined on the slide, there are some important conceptual differences. And they concern things like focus on defense, like low levels of maturity as compared to traditional IT security, dependency on suppliers and change management complexity, and low cybersecurity awareness. We'll go deeper into all of those topics, but for now, I would like to also bring your attention to something like the top risks. So when you think about a company, like just the regular company, you would think about things like data privacy, GDPR, data breach, and stuff like that. We in critical infrastructure are typically more concerned about availability as well as operational continuity in general. So there is that principle, if it works, just don't touch it and it's fine. As well as the so-called cyber physical impacts, where in this case, my concern things like environmental impact and human safety. This is all captured in the so-called STAR model that you can see on the right side of the slide, and it comes from the standard NIST 8183. We'll be operating on this, and it will be one of the important parts of the program as we progress with the slides. Okay, so in order for us to plan a good security program, we need to understand how it all works and how the attacks typically happen. So in the next few slides, we'll go a bit deeper into the difference between attackers' approaches in various stages of the kill chain and the tools they typically use, as well as which parts of the program need to be prioritized for effective protection. Mitre has released a separate attack matrix for industrial control systems. And even on the initial access stage that you can see here on the slide, we start to notice interesting differences in techniques, such as the transit cyber assets, the rogue master, and remote services between the network segments. However, it would make sense to talk about the ICS matrix only if we looked at OT and isolation. The real systems, unfortunately, well, not unfortunately, it's of course the double-edged sword, but they're increasingly interconnected, which means that very few times we can talk about something like the true air gap. It means that both of those kill chains, both of those matrices need to be considered combined. And we'll look at it here. So for example, unless we talk about the opportunistic attackers, most of the times, as fact as many as 4 out of 5, start in IT network. Skilled attacker would likely walk through the full attack chain of IT before switching to operational technology, the OT, where a separate skill and deep knowledge of the underlying operational technology is needed to develop, test, and execute the payload. To further illustrate and be a bit more specific about the most common attack vectors, the two main ones that cause physical consequences based on the Waterfall Security 2024 report so far were abundance of caution, something like a friendly fire if you would like to think about it this way, and the IT dependency. So as you can see, there are other reasons, and direct OT attacks also happen. So we don't want to say it's just IT and that's it, right? But most of the times, it's just a part of the overall plan. This is something that we need to keep in mind as we start to talk about how we secure against that. As mentioned before, achieving operational impact requires different skills and knowledge. One interesting observation of the past few prominent attacks is increased use of so-called living off the land techniques, where built-in capabilities are used for malicious purposes. For instance, Chinese nation-state threat actor Volt Typhoon focuses on more generic tools like WMI command line and PowerShell to conduct reconnaissance activity, whereas Russian linked Sandworm goes beyond that and attempts to execute malicious control commands of microscada to switch off substations in which real world meant unscheduled power outage, and unfortunately it did happen. So here, I'm not really going to go into detail about threat actors and do, like the generic presentation, but rather I'm going to focus on some of the OT attack trends and to see and to consider how they could be helpful in informing OT cybersecurity program. In general, the rule of OT security is as follows. If an attacker gains access to a thing like PLC, like programmable logic controller, RTU, such as remote terminal unit, other controllers, or general level 1 devices, and we'll talk about levels a bit later, those that run authenticated control protocols, then basically the attacker can do whatever they are smart enough to figure out and what the safety protection allows. So again, think about it. Once an attacker is able to get access to the OT network, many times it could be considered as a game over already. It's not always the case, but sometimes it is. And in this case that I'm currently illustrating on the slide, it's the most recent strain of malware for OT named Frosty Goop. It was discovered earlier this year, and it's only 9th known ICS malware. So before that, there were 8 famous cases of malware, but generally there are just 9, and it shows that the area, the focus of OT security here is also developing, and unfortunately developing rapidly from the attack perspective, which means we as defenders also need to catch up. So interesting feature of this malware is its relative simplicity and facilitation of expected commands by using one of the most popular ICS protocols, Modbus. According to Dragos, over 46,000 exposed appliances were vulnerable to it in 2024. Because of this, a large part of the second OT kill chain that we reviewed on the previous slides becomes easier to execute. Not all strains are that simple. The same company Dragos, which has been tracking the malware under the name Pipedream since early 2022, described it as a modular ICS attack framework that an adversary could leverage to cause disruption, degradation, and possibly even destruction of depending on targets and the environment. So it's also named as the Cobalt Strike for OT, and it consists of multiple components, in this case 5, to accomplish its goals. And it helps the attackers to conduct reconnaissance, hijack target devices, tamper with execution logic of controllers, disrupt PLCs, and ultimately it may lead to impacts such as loss of safety, availability, and control of an industrial environment. Again, for us as defenders, it means that less skilled attackers with access to such a malware would be able to cause much more serious damage than before. So it's not just enough, to go run a scanner and then all of a sudden get access to the OT network, or do it, for example, through accessible device somewhere on Shodan. In the past, you would need to understand how it all works. Now with facilitation and now with the tools like Pipedream, and of course there are concerns that many more will be released in the future, then it will become something like a Metasploit for OT or a Cobalt Strike for OT. So again, this just adds the overhead and the headache for the defenders. So we spoke about the initial access and lateral movement. Let's also talk a bit about the impact. I mentioned already that one impact in the energy sector relates to power outages. It's the most obvious one, but it's not the only one, right? So if we recall STAR model, impacts like damage to property, loss of protection, loss of safety are also reflected in the ICS attack matrix. Another scary one is loss of control. So imagine that you have a plant, right? The plant that generates energy that many companies, many organizations, many people depend on. And imagine on this plant, which has a lot of those complex and potentially dangerous processes, you see how a cursor starts to move all of a sudden. What's more is that imagine that you are not able to do much. You can shut it down, which is risky and costly. In fact, sometimes it could be like millions per day. And you need to be bold enough to make this decision. If this scenario is not planned in advance, so imagine again, you're a plant manager, you're an operator, and you see that and you don't know what to do. Maybe you shut it down, then you turn it back. In fact, even shutting down again is a problem, but imagine you did that. Then you come back, you turn it on, everything works. And then let's say in a few days, it comes back again. So if this scenario is not planned in advance, and if you have not considered your defenses, this ultimately may result in catastrophic consequences. And again, most of the times, at least so far, we see that the attackers are really targeted and persistent. So it's not just some random folks going there and doing it for fun, but rather those who are after one of or more of those impacts. So as we now have a pretty good understanding why and how the OT impacts happen, let's introduce one of the methods that is used in OT that is called CCE. It is translated as consequence-driven cyber-informed engineering. So again, it's like a really complex sentence. Again, consequence-driven means we look at the consequences. Cyber-informed means it relates to cybersecurity, of course. And engineering, it's generally about how we approach that as engineers. The flow here is actually really simple. So when in IT, we focus on reduction of the likelihood, in OT, the likelihoods generally are already rather low. However, because the impacts are catastrophic, we need to manage the consequences even sometimes before than the likelihoods. Again, we will talk a bit more about the prioritization. It's not as simple as just to say, okay, we care about the impacts and whatever are the protective controls, we don't care so much. No, of course, there are some reasonable things that we need to do from the likelihood perspective. But then again, it is the catastrophic impacts that we are mostly worried about. And the three basic steps here is that we need to identify which areas are the most high consequence ones. Then we need to understand whether a cyber attack can cause them, because again, in the past, there were things like air gap. There was like that heavy machinery that is not connected to the internet. And, the plant manager will say, yeah, you know what? I don't care about hackers. Like I operated manually. It's not connected anywhere. We are safe. Now, of course, it's not that simple. And then if the first two instances are correct, so we identify the area, we know that the cyber attack can cause it, then the tricky part is that we need to do something so that it cannot cause that, so that the impact is contained. And of course, here, the complex part is like, what do you do, right? So this is where you need to sit and have a discussion with your plant and operation teams. Of course, you need to understand how exactly it works, and there is no one generic answer. However, there are some examples. You may consider things like secondary supply. You may consider things like manual control, for example, like a fallback. Yes, you see that there is a cursor moving, but if you can switch to manual and you can still operate, well, that's great. You already have another way of operating. You may consider things like separate safety system, pressure relief valves, different procedures on how to do that, and so on and so forth. So you see here, that's one of the complexities of OT security is that it's not just about cybersecurity as we are used to that. It's not just to say, hey, you know what, use MFA, use firewall, have a backup, and you're good. No, it is required to understand the operational technology processes of how the plant actually works, and it is required to work with the teams to make sure that the protection is effective. One quick note here, so I show you the matrix on the left, which is severity times likelihood. I really don't like this way. I decided to demonstrate that because it's much easier. However, if you ask me, and by the way, I didn't make it big part of the presentation. A much better approach here would be considering a thing that is called cyber risk quantification, CRQ, where you would know exactly what are the loss drivers and the impacts, as well as the threat event frequency and susceptibility to specific events. So you would map the scenarios, you would understand your program, your controls, and your general security posture from both the capability and coverage perspective and the reliability of those controls. And then with math methods such as Monte Carlo, you would be able to calculate the ranges of likely losses. We generally advocate for that, but again, this is not a presentation about CRQ. Although, if you can, I think you should already start thinking about how your risk outputs be a bit more meaningful than, high, medium, low. So anyway, we spoke a bit about CCE, consequence-driven cyber-informed engineering. Let me talk a bit about how we could identify the high consequence impact areas. So we spoke about what we could do, but then again, where the high consequence impact areas lie. Again, it's not just one answer for everybody, but some examples here include things like physical infrastructure and the failure of, let's say, upstream and downstream systems. So if just one of those systems fail, potentially the whole system may be failing. And here you might want to consider redundancy. Then using the same technology across multiple systems, it of course introduces potential for multi-site failure. And unfortunately, it did happen in Ukraine when they were targeted and three different substations were disabled because it was the same technology. And potentially the solution here could be that not having all eggs in the same basket, that specific protocols, if failure is detected in one, redundancy, and so on and so forth. And then what we already mentioned, reliance on automation and control. So if successful attack causes loss of view or loss of control, and which are some of the primary technical impacts of attacks in industrial security, then potentially we might want to switch to operate manually. Or if we're not able to, well, tough. Then you just need to shut it down, then hopefully restore from the backup, and then monitor and again hope that the attackers weren't able to penetrate that deep and persist. So you see, we discussed things. All of that was kind of the introduction, not just to jump into and say, hey, there are frameworks, let's just build the program and we are secure, right? So when we have CCE and typical attack paths in mind, we can start thinking about the appropriate frameworks to base our program on. I think by now it should be pretty clear that something like ISO 27001 or even NIST could only partially be helpful. According to the analysis of VERF, and is supported by many national regulations, by the way, including NIST2, but also it's in the US, in the APAC region, and many other national regulations around the world, IEC 62443 is considered the so-called golden standard for OT security in general. So we cited this one, 62443, also, as well as one of the oldest frameworks in the energy security specifically, the American NERC, and came up with our own OT minimum security standard, OTMSS, that consists of top 9 sections and 37 controls that form a baseline for our sites. Again, we have, I think, 49 sites around the country. Some of them are really remote, some of them are really critical. And for example, one which I've been to just yesterday is accountable for 20% of all energy on the island we are based on, which is the largest island of the Philippines. For those ones that are really large and critical, those generating facilities above certain thresholds require additional and stricter controls. And generally, the definition of criticality, which is already included in the frameworks like NERC, is also something that your business continuity management teams should help you with. So again, it would be nice to end here and say, yeah, use existing framework, optimize it for your context. But there is always one question which invariably comes up, which is, where do you start, right? If you already have a mature program and you just marginally improve, then yeah, you just say, here is the recipe, go through that, implement that, you're fine. But if, let's say, you are at the earlier stage, or let's say there is a merger and acquisition or a new site that is built, like which controls are more important? So again, think about it. What would you prioritize? Would it be long-term and high-effort controls, or would you start just with long-hanging fruits like default passwords? What is more important, raising awareness or dedicate your very limited resources? And by saying very limited, typically you don't have a lot of OT security experts in your team, unless you are very lucky, which means that you always need to manage your scarce resources, such as time, such as manpower, such as budget and so on, to implement something. So would you do this, or would you prioritize log collection? These are, maybe you already have an answer in your head, and if there is a discussion, maybe these answers are not necessarily the same. So in our view, because we know that all of them need to be implemented ASAP, we thought of how to approach that. And our approach here is to look at the both ends of the kill chain that we discussed. So the most obvious entry points, something like internet accessible remote services that we can get compromised right away tomorrow, or even today, in fact, and the impact containment in the spirit of CCE. So this is what we've done. When we were just starting, and here I would like to talk a bit about the SANS. So we considered the top 5 critical controls. So what I'll do here, and to conclude the presentation, I will go one by one through those 5 critical controls and discuss how we approach them for our facilities. So this is a work that was published in 2022 in collaboration with Dragos, Sons and Dragons, and these 5 are considered must-haves before we proceed with something more sexy and complex. Of course, again, it doesn't mean that you just need to do those. If you believe, for example, that your industry, your specific geography, and your context that you know better than anybody else require you to do something else, you're of course still allowed to. It's more of a guidance, but a helpful one. Okay, so let's go through those top 5. Number 1, and again, it sounds very rational, is to be prepared for incident response plan, right? So we know that sometimes it happens, maybe not as often with the cyber physical consequences, but it does happen. So the objective here would be to develop a comprehensive incident response plan specifically designed for ICS environments. And again, it is important because many times we know what to do if there is a phishing email, maybe even ransomware, which, by the way, of course, can affect OT. But sometimes when, again, what would you do if you see a moving cursor? What would you do if you see some anomaly, but you're not sure if it's a cyber attack or not? Well, this becomes a bit more tricky, and this is why you need to make sure that you account for specific scenarios, and you encompass procedures like detection, reaction, and recovery from cybersecurity incidents. So as mentioned before, we need to consider the likely attack vectors and the important impacts per site, which will be different between things like a coal plant and a geothermal plant, which is our reality. So we have thermal, we have renewable energy, then we have distribution, and again, some of them depend on water, some of them depend on coal, some of them depend on oil, sun, and so on. And of course, the design of those plants and the possible consequences also different. One thing that helps us here are the bow tie diagrams, one of which you can see on the slide, and they help us to map the protection controls in place. And they may include traditional cybersecurity controls like the firewalls and others which you may have, as well as the physical and safety controls, which become super important here. For example, pressure safety valve. So one of the diagrams, again, that you see on the slides, presents what are the steps here to prevent explosion. So again, there is a physical disaster kill chain, which may or may not be caused by a cybersecurity incident, and what is in place. So we know that there is safety, we know that there are automatic systems, but ultimately, if all of them are bypassed, well, we get the explosion, right? So by combining the safety diagrams like this one and cybersecurity, we are able to create something that will be more resilient long-term. And of course, this is our goal. So number 1, incident response plan. Number 2, a defensible architecture. And this is the famous Purdue model, where the objective here, of course, is to construct a network architecture that effectively segments and isolates critical systems on multiple layers. I will not go very deep into detail. It's freely available on the internet, but generally, this is the standard way of how you would like to structure different layers in your plans. So the goal here is to minimize the attack surface and reduce the potential impact of cyber incidents that we just discussed. And even though it's not immediately on one of the ends, so again, it's very simple to think, okay, here's where we usually get the attacks, here's what is the impacts, let's fix those. Well, it's somewhere in between, but again, it's one of the very important aspects of cybersecurity in order to manage the impacts. So it adds up to this sexy word of resilience. Number 3 here relates to visibility and monitoring. And yes, the objective is to make sure that we have the continuous monitoring of ICS networks to properly detect anomalies and potential threats. So this should be straightforward. And if you don't have visibility in what happens in your OT networks, you're just not well equipped to quickly respond. And whatever you wrote in the incident response plan, I mean, good luck with that, right? In the past, it was a challenge. I would say 10 years ago, it was very few networks and definitely not 100% coverage where you would have that. Now it's a fairly standard requirement. And in fact, it was introduced in NORC-CIP, that standard for energy cybersecurity in the US, as mandatory for BESS systems. So there are multiple vendors on the market. Specifically, we use Clarity, but I'm not going to here to be the vendor selling or anything. Any pretty much works. The most important here is that there are timely alerts, there are root cause analysis, and that you're able to integrate that into your SIEM for effective incident response. Number 4, secure remote access. The objective, obviously, is to implement secure controlled access solutions to manage and monitor access to ICS environments. So again, conceptually, it is quite straightforward. Of course, we want secure remote access. Of course, we don't want to have random services out there which are easily available to attackers. However, technically, it's not always that straightforward. So you need to consider all the multiple stakeholders you have, from third-party technicians to remote employees to partners and so on and so forth, who might need access to critical parts of the network sometimes for troubleshooting or maybe for legitimate activities such as transmission, for example, or regulatory bodies that need to have some visibility. So, of course, it's possible to build your own jam box and monitor it. And I mean, you can be as creative as you'd like, but currently there are enhanced SRA solutions on the market that allow things like MFA, strict access controls built in, anomaly detection that's already integrated with the previous tools, and more. So again, the use of vendor is not important, but having an effective solution that will allow you to say that, yes, for the identified entry points, the remote access is secure, it is important, and you need to make sure that it is in place. Finally, the risk-based vulnerability management. So you might remember from the first comparison table that change management in OT is a completely different story. In IT, you would likely want to fix a high-risk vulnerability right away. I mean, of course, I know it's not happening 100% times, but generally, when you have an important asset and a high-risk vulnerability, you would at least push to do that, and most likely, with some support, you would be able to do that in a few days, weeks, depending on how mature your vulnerability management program is. Unfortunately, it's not the case for OT. Remember, again, that principle, don't touch it if it works. And what if the solution is not available? Like, you probably heard about workstations that run on Windows 7 or even XP, and it's unfortunately a rather common thing in OT environments. And then imagine, okay, yes, you know that it's important, you know that the solution is available. Will it work in the environment? Will it not run into operation failure? Remember, one of the largest reasons why impacts happen is abundance of caution. So imagine you decided to patch a vulnerability and you caused a downtime that costed your organization, I don't know, a couple million. Well, that wouldn't be optimal, and I'm sure your senior managers won't be super happy about that. So what we did is that we approached the problem with a so-called ICS vulnerability oracle, which we built based on the original article by Dale Peterson, one of the legends in OT security, back in 2020. It helps us to make decisions based on the criticality of the assets and schedule batch updates during planned patch windows. So we consider things like exposure of the asset in question, potential safety impacts, and impact of the process if it is compromised. We made it open source, so after we distribute the slides, you are free to just scan the QR codes, copy that, and play with that if you'd like. We hope that it could be helpful for you. So finally, I will now get closer to the conclusion. I hope you found the presentation interesting and helpful at least in some way. So there are the key takeaways from here. So first, that's SBOM and firmware security. You might heard about things like that. They're cool, but you need to take care of the basics first. You need to understand really deeply about how the money is generated and generally what is the context of your environment. We suggest to start from the end, or rather both ends, but of course there are some things like defensible architecture that you still need to keep in mind for resilience. You need to make sure that you have visibility and effective incident response, because again, the impacts there is something that not to be played with. And then finally, again, I didn't stress this point too much, but if you can, please try to quantify. I really don't like when we, as cybersecurity folks, start to sell, well, what's it in English? Vender humo, sell smoke. So yeah, try to make it more objective and try to appeal to the decision makers with the money so that you have their support. With that, I would like to thank you all for watching. I would appreciate if you could scan this QR code and leave your feedback after these presentations, as well as send any questions now or after that. Thank you very much. Hope you have a great day and stay safe.
Thank you, Alexander. I think this is a very insightful presentation for many of us. So right now we have about 5 minutes for any questions. So if anyone has any questions, feel free to drop them in the chat, and we have about 5 minutes to get at them. Okay, so if people don't have any questions, I think we can stop this here. I saw a lot of thumbs up and some compliments in the chat. So very good presentation, Alexander. And thank you everyone for attending.
Thank you very much.